LeetCode question 199. It says we are given the root of a binary tree and we need to imagine that we are standing on the right side of it and we need to return the value of the nodes that we see from top to bottom. So over here we have got 1 followed by left child of it as 2 followed by right child of it as 3. Okay, then we have got null. This is null, that is the left child of 2 followed by 5, the right child of 2, null being the left child of 3 and 4 being the right child of 3. Now we need to imagine that we are seeing from this side. Okay, so upon seeing from this side, the elements which appear to us would be number 1 followed by this. At level 2 we have got 3 and at level 3 we have got elements as 4. So we need to return a vector called answer which has got all these elements which we could see from the right. Okay, so let me show you how we will solve this. So our first step would be to create an answer. So step 1 would be to create an answer vector. Okay, now since in the question the root would be given to us, okay, and this would be traversal, so that's why we would require a queue. So I create a queue. Okay, so I take the root which is given to me. Okay, the root over here would be 1 which is given to me, so I push that into the queue. So in my queue I have this root as 1. So my next step would be to my step 2 would be to write a while loop until my queue is empty. Okay, so my queue is so right now my queue is not empty. Okay, so I find my size of the queue. This is 1. Okay, now I start iterating from I is equal to 0 to I less than the size. Okay, so my I is equal to 0, which is true, and I use the condition I plus plus over here. So my I is equal to 0, so we can go ahead. Okay, so what we do is basically we take the front node. So we have the node which is the front of queue, so we get this as 1. Okay, and then we pop this, so 1 is removed from the queue. Now we check if my I is equal to size minus 1. So my size was 1 and my I is 0, so I is equal to 0 and my size minus 1, which is 1 minus 1, which is 0. So this over here is equal to this. That means we are seeing the rightmost element, hence we push this into the answer. So we push answer dot push the value of this node. Okay, so in my answer I have got 1. Now my next task would be to check if the node has got left child and the right child. So I check what's node of left. So on the left we have got 2, so we push this into the queue. So we push 2 over here and my right is 3. Okay, so we push 3 over here. So we have got these elements in the queue. Now we repeat this while loop again. Okay, we do while my queue is not empty. Okay, so my queue is not empty, as we can see we have got 2 and 3. Okay, so I find the size of my queue. My size of queue is 2 since elements 2 and 3 are present. So I iterate from I is equal to 0, I less than size, I plus plus. So now I find my front node and then pop it. My front node is 2 and then I take it as 2 and then pop this from the queue. Okay, so let me check if this is the rightmost element, and the formula for that will be if I is equal to size minus 1. So my I is 0 and the value of size minus 1 is 1, which is not true. Okay, so we don't push this into the answer. It means this is not the leftmost element. Now we check for the left child of 2 and the right child of 2. So what we see is the left child of 2 is null and the right child is 5. So this is null and this is 5. Since this is null, we do not push this into the queue and we push 5. So over here 5 is pushed into the queue. So so now my I is 0. 1 minute. Over here we completed our first step. Okay, now my I is updated to 1. Okay, so my I is updated to 1 and my node over here would be the front value of this. So I take 3 and then pop it. So my this is 3, front node is 3. Now I check if my I is equal to size minus 1. My I is 1 and the size in this was 2. So this is 2 minus 1, which is true. That means we are seeing the rightmost element and we push this into the answer. So we put 3. Now we check for children of 3. So the node of the left, what we have on the left and right, let me see for element 3. So on 3 for the left we have got null and this is 4. So we push 4 into the queue. So over here in my queue I have got 4. So now I come out from the while loop. So after coming out from the while loop again, sorry, after coming out for the for loop, I'm again in my while loop. My queue is still not empty and the size of my queue is 2. Okay, so I go from I is equal to 0, I less than size, I plus plus. So I take my front node. So my front node over here is 5 and I pop it. So I take 5. Now my I is equal to 0 and my node is equal to 5. Now I check if I is equal to size minus 1. My I is 0 and size is 2 minus 1, which is 1, which is not true. Therefore this is, I'm not seeing the rightmost element. Now if I go to the left child of 5 and the right child of 5, so these are null. That doesn't make sense, hence we do not push this into the queue. Okay, now my next step, now my I is, so now my I is 1. Okay, so my node over here will be number 4. So I check for if my I is equal to size minus 1. This is 1 and the size being 2 minus 1, which is 1, which is true. That means number 4 is the rightmost element that we see. So we push this into the answer. Now I check for children of 4. Children of 4 is a null. The left child is a null and the right child is a null. So we don't need to push anything. Now we come out for the for loop, and when we reach and when we see the queue, it's empty. Hence we come out for the while loop. So we successfully are able to obtain this. So I'll give you a pseudocode. So my first step would be to create a queue. Okay, create a queue and also an answer vector. Okay, my second step would be push the root into the queue. Okay, and then I run a while loop till my queue is not empty. Okay, in my while loop I will find the size of the queue and then run for y I is equal to 0 till I less than size and I increment I. Okay, so I find the front node and then pop it. Okay, and this is the most important step. So if my I is equal to size minus 1, that means I have seen the rightmost element. Therefore I push in answer and then I check for children. If the children are valid, then I push it into the queue. Okay, and at the end I return my answer. So over here my first task would be create an answer vector, and that we would be returning at the end. So my first check would be if a null pointer or if nothing is there in my root. So if nothing is there in my root, in that case I return my empty answer vector. Followed by this I create a mutable queue. So I use vector deck for it. I create a new copy of this, and then my next step is to push this. Let me use this as queue. So to push the first element, that is the root element, so I do pushback of my root element. Okay, I unwrap it and then push this. Okay, now I need to run the while loop till my queue is not empty. Okay, I run the while loop till my queue is not empty. Okay, so after running this loop I find the size. I find the size of the queue. So this is given by queue dot len, following which I need to check for the rightmost element. So I start iterating for I in 0 to I in level size. Okay, so when I reach here I find I pop the front node, that is I get the front node. So this will be queue dot pop the front node, and then I unwrap it. So I create a reference of this. So I use the borrow function. Okay, so now if my I is equal to level size minus 1, that means I am seeing the rightmost element. So I push this into my answer. So for this I push the node reference, the value of it. Okay, now I need to check if this has got left child or right child. So I say if sum left is equal to node reference, if it has got this left child, then I clone it and I need to push this. So I push this into my queue. Okay, similar step I need to do for my right child. So I say this is right, and over here this would be right as well. So after coming out from here, that is while loop, I've got the answer, so I need to return it. The next thing, since we are using vector deck, we say use standard collections, and this would be vector deck. Okay, let me run this. So I use standard COLL collections. Okay, this U would be small. So submit it. Let's see if it passes all the test case. Indeed